Okay, good afternoon, everyone again. And it's Friday and it's almost the weekend. So gusto na nating lahat magpahinga at enjoy naman ang dalawang araw after probably a full week of lots of requirements or a lot of work. So let's get going. Now, some housekeeping matters first. I don't know if I already announced that the deadline for worksheet number 3 is extended. So let me just switch to Canvas. I guess worksheet number 3. Oh, there you go. It is extended until Wednesday, October 6th. Kasi dun sa kabilang section, I wasn't able to finish the coverage of the study guide for this week. So some of the topics will be discussed in the lab sessions on Monday. So I decided to give you a couple more days to finish worksheet number 3. So ang deadline niya na ng worksheet number 3 is on the 6th, right before midnight. And pero may tatlo na kayong classmates na nagpasa, so kudos to you guys. So, all right. So, ano na nga ba yung nagawa natin ngayong week? So this week, we already look at the inner structure of propositions. So tinignan na natin ano yung mas specific form ng mga propositions. Now, the propositions we are dealing with has three parts. Number one, specified na siya sa isang subject o yung tinatawag nating term. The term can be a constant or it can be a variable. So ito yung subject ng proposition for which we are claiming a certain statement or which we are describing or which we are talking about in a certain sentence. So it's usually either a constant or it's a variable. If it's a variable, then we can talk about the domain of that propositional statement, wherein the domain is the set of all possible substitutes for the variable. Okay. Tapos part number 2 is a predicate, which is actually the actual statement that is used to describe the subject, or this is whatever we are claiming to be true for the certain subject involved in the statement. Usually we denote it by capital letters. I guess we have seen a lot of examples of this last time. And then the third part, I think this is the most striking difference from the types of propositions you dealt with before. Meron ng quantifiers, yung mga predicates o yung mga propositions natin ngayon. And then there are two types of quantifiers. We have a universal quantifier, usually denoted by the inverted A, and an existential quantifier, which is denoted by the mirrored E. So a statement that is quantified universally will be true if we are able to show that it is true for all elements of the domain. It will be false if you can give me a counterexample kung saan hindi totoo yung specific universal proposition na yun. Now, on the other hand, if you have a statement that is existentially quantified, meaning it is only claiming that there exists an element of the domain that satisfies the statement. So ibig sabihin, makapagbigay ka lang sa akin ng isa kung na magiging true yung proposition, then the existentially quantified proposition is true. Now, it's a little bit harder to show that an existentially quantified proposition is false because you have to show me the impossibility of having an element of the domain satisfying the predicate. Okay, so I guess that's basically the summary of what we did last time. And then I was very happy with our last session. You guys really participated then. So sana ganun uli ngayon. And I will need your help because again, I'll be pausing a lot. So, all right. Oh, may nakalimutan pala akong announce additional housekeeping matter. I already finalized my schedule. So I have now my consultation hours. They are from 1 to 3 p.m. from Monday until Friday. So if you have some questions about Math 101 or questions about anything math related, or meron kayong tanong about your academic career as a student or university life, or kung wala lang gusto nyo lang na makakausap, ka-hangout, so you can drop by my online office from 1 to 3 p.m. Monday to Friday. I created an MS Team channel, or an MS Team. I called it NJAE Online Office. And then I added everyone in the team here. Tapos meron na dong permanent meeting link for the consultation. So you can enter the room from 1 to 3 p.m. Monday to Friday. I'll try to be there, but in case you entered at wala ako doon, just send me a chat or an email, and then I'll join you shortly. Okay? Baka minsan nagtitipid ako ng data, so hindi ako mag-login dun sa MS Teams or mag-open ng meeting. But feel free to enter the meeting, and I'll meet you there. Now, if you are not available during any of these times, then and then you have something important to consult with me, so pwede naman mag-send kayo sa akin ng email probably 1 or 2 days before to set up a custom appointment. So we can talk about our schedules and see when can we meet virtually. Okay. So yeah, again, consultation hours 1 to 3 p.m. Monday to Friday. All right. Now, let's continue. Balik na ulit tayo sa business. So let's look at example 14. I guess we finished everything prior to this. So I think naiwan natin from last time. So here we have two predicates. Now the first one is statement Z about X. X is an integer, and the statement Q about X is a rational number. Then we want to translate the following propositions into symbols. So let's look at statement A. Statement A says every integer is a rational number. So ito yung isang example na nakita natin last time na hindi literal yung pagkakatranslate niya into symbols. So kailangan natin i-analyze siya, magdadagdag tayo ng isang step dun sa translation. Because what is the spirit of this statement? It is claiming na lahat ng integer ay rational number. So it seems that being an integer is sufficient for us to conclude that that certain number is a rational number. So every integer is a rational. So ang gusto niya sabihin, kapag ka meron kang integer, automatic na siya ay rational number. Okay? Now, in symbols, so since this is claiming this statement is true for all integers, so ang quantifier niya ay for all. Okay? And then sabi nga natin dun sa analysis, parang enough pala or kiniklaim ng statement na enough na maging integer siya para maging rational number siya. So that means if it is an integer, then automatically it becomes a rational number. So our statement here is Z about X implies Q about X. All right. So I hope you get the you are now starting to get the hang of it. Kasi ito yung medyo isang example ng tricky na statement kapag ka translate into symbols. Okay. Now, let's see. Statement B. All right, let me see. Any volunteer to translate statement B into symbols using the variables declared here? So if you want to recite, kindly use the raise hand button, and then I'll recognize you. Either unmute yourself or put your answers in the chat after I recognize you. Okay, go, Crizel.
For B po, Z of 5 po, since sinabi po na 5 is an integer. And Z of X is an integer. So, Z of 5 po.
Okay, thank you, Crizel. That's perfect. So statement letter B is an example of a predicate, a quantified predicate wherein the subject is a constant. So yung statement Z about X, si X ay integer, pero ang statement B sabi si 5 ay integer. So remember that the term can be a constant. So kaya Z of 5 in translation, okay? How about part C? Volunteers? Yes, Prince. Nauna yata si Prince. Next ka na lang, Mark. Okay, so Prince typed in there exists an X. There exists an X such that Q of X and a Z of X. Okay, and I guess this is correct. So thank you, Prince. Complete pa yung symbol, no? Saan galing yung there exists? Copy paste ba yan sa Word or merong keyboard shortcut? So if you want, you can share it with us. Pero let's see, some rational numbers are integers. So ibig sabihin, kiniklaim ng statement C na merong mga x's. Kasi some, so there exists. May mga x's na rational number sila, so q of x, and they are integers at the same time. So great, that's correct, Prince. Statement D. Mark Robert, you want to answer part D? Or Ayomo? So anybody else aside from Mark Robert? No integer is a rational number. Medyo tricky pala to, no? Okay, if nobody wants to answer, let's think about it together. So part D, no integer is a rational number. So hindi yata pwede yung direct translation or hindi madali yung direct translation. So let's analyze it a bit. Walang integer ang rational number. So ibig sabihin parang this is a claim of something being false about all integers. So walang integer na rational number. So ibig sabihin kapag ka siya ay rational number, ibig sabihin automatic, hindi siya pwedeng maging rational number. Kasi kung integer siya, hindi siya pwedeng maging rational number. Teka, inulit ko lang yung una kong sinabi. So wala daw integer ang rational number. So kung siya ay integer, imposible na maging rational number siya. So, and this will work for any integer. So we can symbolize it probably as for all x. Dahil kung integer siya, imposible na maging rational number siya. Kasi nga, walang rational number ang integer. Okay? So this is just one way of writing this statement. Actually, there is another one. Pwede nyo rin siyang sabihin na for all x, q of x implies not z of x. Tama ba? Kasi kung rational number siya, hindi siya pwedeng maging integer. Kasi nga, wala daw integer ang rational number. So pag binigyan kita ng rational number, sure ka na hindi siya integer. Kasi nga, kapag walang integer ang rational number, so this guy could be your translation for statement D. Okay? Tapos kung i-compare nyo to, sir, parang ano to, kamukha nung rules of equivalence, di pala rules of equivalence. Ito yung, rule of equivalence from last time wherein we just took the contrapositive of this statement, if you remember. So if not, we'll go back to it, I guess, in our succeeding materials where when we try to prove statements about quantified predicates. But yeah, hindi unique in translation. Just make sure that they are equivalent with each other. Okay? Is that clearer? Posibleng may iba pa kayong maisip na representation like the equivalent representation using material implications. So posible nyo rin siyang gamitin. But I guess these two are the more obvious representations of statement D. All right. Statement E. Some integers are not rational numbers. Okay. Yes, Rian? Okay, Rian also typed in her answer. There exists an x such that zx and not q of x. Okay, so some integers are not rational numbers, so obviously we'll have the there exists an x. Meron daw mga integers na hindi rational numbers, so dapat si x maging integer muna, and at the same time hindi siya rational number. So thank you, Rian. This is perfect. So I guess you now are getting the hang of translating propositions into symbols. So because crucial tong step na to, kasi ang susunod natin gagawin, magte-test tayo ng validity. Magpo-prove tayo ng validity or invalidity of propositions that are quantified. So the steps that we are looking at will take us or actually would be very crucial kasi nga pag mali yung translation, so ibig sabihin may hirapan or posibleng mali yung magawa niyong proof later. Okay? Okay, so you have the answers here. Okay, I guess you can try exercise 15 later. Now, translating statements. So the next examples will be showing us how to translate mathematical statements into symbols. So yung English statement ng isang mathematical claim o ng parang isang theorem, yun yung tinatawag nating informal language, or at least that is what is considered by the work text to be an informal language. So yung pag nagbabasa kayo ng books, the way theorems are presented, usually they are in informal statements. So for instance, statement A in example 16, all even integers have even squares. So this is actually purely English language, and a layman can understand it even if wala siyang knowledge about mathematical symbology, right? And also look at B. There exists a continuous function f such that f is not differentiable. So basically, we all avoided the use of any mathematical symbols aside from those really necessary, like the function f. So parang plain English siya. So yun yung mga informal statements natin. Now, if we want to translate it into a formal language or formal mathematical language, we'll try to use symbols. And these symbols also involve the use of quantifiers. So magiging specific tayo sa pagde-define ng mga sets, paggamit ng mga quantifiers, and all symbols na na-introduce na sa atin. So if we look at the solution here in the work text, the translation of the informal sentence or claim that all even integers have even squares is this guy. So una, dahil wala pa tayong convention para sa set of all even integers. So that's why the statement started with declaring that from now on, we will use the double struct E para sa set of all even integers. So let's just adopt it for the rest of the semester. So double struct E is the set of all even integers. And it is claiming that all even integers. So that means for all x that belong to the set E, meron siyang even square. So kung even yung square niya, so ibig sabihin si x squared, dapat mag-belong din dun sa set E. So this statement here, which is a little bit different from the informal statement, is what we call the formal statement. Kasi dito gumamit na tayo ng symbols, naging particular na tayo dun sa quantifiers. And it is actually much easier to prove this statement, or at least yung pagpaplano natin on how to prove this statement is clearer rather than looking at the plain English statement. Okay. Now for statement B, there exists a continuous function f such that f is not differentiable. So probably here we'll start with defining what are the sets of continuous functions and of the differentiable functions. So that's again the first sentence here. There exists a C upper zero, or sorry, let C upper zero be the set of continuous functions and set D be the set of differentiable functions. And then the actual claim, sabi rito, there exists. So meron kang existential qualifier or quantifier. There exists what? A function f. So there exists an f that is continuous. So meron nag-exist na f mula dun sa domain ng propositional statement, which is the set of all continuous functions, such that f is not differentiable. So f doesn't belong to the set E. Okay? Minsan kung sasabihin nyo parang wala namang masyadong pinag-iba yung informal at saka yung formal language. It's just that in the formal language, we are trying to symbolize everything and write it in a more mathematical fashion, whereas the informal language is more designed for a layman's perspective. So para kahit hindi siya nag-aral ng Math 101 o hindi siya na-introduce sa formal mathematical symbols, so maiintindihan niya kung anong gustong sabihin ng statement. But the drawback of that, medyo minsan hindi clear kung ano yung gusto nating i-prove or yung claim dun sa statement. Okay? Now, questions so far? Wala pa naman. So puro translation lang, no? So let's try exercise 17. Translate the following into formal statements and use quantifiers and variables. So statement A, all real numbers have non-negative squares. So do you guys, any volunteer? Ano pala, no? Pwede nyo sabihin verbally and then I'll try to write it. Or pwede akong mag-open ng whiteboard. Oh yes, Trisha?
For all x that belongs to the set of real numbers such that x squared is greater than 0. Ay, greater than lang.
Dagdagan or equal to, right?
Ay,
Kasi yung claim ay non-negative, right? So
Okay.
hindi siya negative, so dapat siya ay either positive or equal to 0. Okay, so dahil na-define na naman or meron na tayong notations para sa set of all real numbers, hindi na kailangang i-declare yung variable na yon. So once na-define na natin, gamitin na natin siya from now on para kukonti yung isusulat natin. So Trisha is right, thank you. So this statement can be shortened into this symbolic statement over here. Dati merong rules sa English pag nagte-take kami ng Eng 10 nung estudyante pa ako, which is not that long ago. Disclaimer kagad, no? Meron daw rule na bawal i-start yung sentence by a symbol. So yun yung sabi sa amin sa Eng 10 nun. Pero meron talaga akong isang sentence dun sa aking proposal na hindi ko siya ma-phrase na English na hindi ako mag-start sa symbol or sa variable. So sabi ng teacher ko, sige, yung mga math exempted na dun sa rule na bawal mag-start with a symbol. So true enough here, we can have a sentence that is purely made up of symbols. Pero ngayon, I still try to avoid starting my sentence with a symbol, especially if it's an informal paragraph or it is actually something that is written for a non-mathematical audience. So, yeah. Pero yon, lagi tayong may nakukuhang exemption. Tapos isa yun sa mga dahilan kung bakit nag-institute na ng Math 195, isang research course, which is different from the other sciences. Kasi nga, merong mga peculiarities yung mathematical language. Okay? Okay, let's try part B, or statement B. No real numbers have squares equal to -1. So, who raised their hand first? Tingin ko, sinong nauna? Oh, Kit.
For all x
Kit
element
of... Anyway, all right, go ahead, Kit.
Okay po. For all x, which is element of real
type it in the comments.
Ay, no. Rinig po ba ako, sir?
Oh, yeah. Ayan. Mas okay na ngayon.
Ayan po, sir. For all x, which is element of real numbers, x squared is not equal to 1 po.
-1.
-1 po. Sorry po.
No problem. Yeah. Yeah, that's correct. So for all x in R, x squared is equal to x squared is not equal to -1. Kasi sabi, walang real number na ang square niya ay -1. So any for all, okay, I think this is fine. Meron pa bang posible? May inisip akong symbol pero hindi ko na lang siya i-introduce para kukunti lang yung symbols natin gamitin. Okay. So how about statement C? There is a positive integer such that m squared is equal to m. Volunteers? Oh, yeah. Go, Mark Robert. Nagta-type yata siya sa comment or nagloloko na naman ng audio ko. Okay, while waiting for Mark Robert, kung nagta-type siya sa comments, maybe next time we can try opening a whiteboard here in Teams, lalo na kapag nasa proving part na tayo. Mahirap magdiktahan lang or magsulat sa comment section. So if you guys have if you have your mouse with you, or if you are joining the meeting via a mobile device, na touch screen, I think we can make the whiteboard work. But again, there's always the chat and the voice channel para mag-exchange tayo ng ideas. So I think Mark sent in his answer. There exists an M in Z. So I think sinulat niya. There exists an M in Z greater than 0. And M squared is equal to M. Great. Thank you, Mark. That's correct. There is a positive integer. So there exists an M that belongs to Z. Pero hindi lang Z. Pero dapat si M ay greater than 0 din. Kasi positive integer lang. Such that M squared is equal to M. Okay, perfect. You can also write it this way. You can say there exists an, you can declare the set of all positive integers. So you can let Z plus be the set of all positive integers. Then for all X in Z plus, there exists an M in Z plus such that M squared is equal to M. All right, so yeah, you can declare a shorthand notation para kukonte yung propositions na involved. Kasi later, pagka itetest natin yung validity, kailangan nyo pang i-check kung si M is greater than 0. So baka additional step yon dun sa gagawin yung proof of validity. But this is perfectly valid. Mas efficient nga lang siguro if we adopt a more another notation or a simpler notation for the set of all positive integers. Okay. That reminds me na siguro introduce ko na itong mga notations na to. Kapag ka meron tayong number sets na familiar na tayo from before, like say set of all rational numbers or kahit sa set of real numbers. Pag gusto natin yung set of all positive such numbers, lagyan lang natin sila ng superscript na plus. Okay. So yung Q plus, ito yung set of all positive rational numbers. Yung R plus, siya yung set of all positive real numbers. Then kapag gusto nyo naman yung negative, so lagyan nyo lang ng negative na superscript. So Q minus and R minus, these are the sets of negative rational numbers and negative real numbers. Of course, pwede rin to sa integers. Same rule yung gagamitin natin. Pag gusto nyong isama si 0 dun sa set, bilugan nyo lang yung superscript. So yung Q plus circle, ito yung set of all non-negative rational numbers. Bilugan nyo yung R plus, yung bilog that stands for 0, ibig sabihin included si 0 dun sa set. So it's just, this is not just the set of all positive real numbers, but the set of all non-negative real numbers because we included 0. Ganun din yung rule, pag binilugan nyo yung negative superscripts, I'll take to it na yung number sets, kinuha nyo lahat ng negative including 0. All right? So those are a bunch of new notations that we can use from now on. And then let's see. Okay, so here are some more examples, but this time this would be the other way around. We'll start with the formal statements. This is example 18. So we'll start with formal statements and then we'll translate them into informal ones. So basically, you will need to interpret ano yung gustong sabihin nung statements as if you are talking to a layman. Okay. So here we adopted some more notations. The double struct P is the set of all prime numbers, and the double struct O is the set of all odd numbers. Okay. So let's see some examples here. So example A, there exists an X in R such that X squared is equal to 2. So basically, yun yung symbol. So parang ano lang, isusulat lang natin in plain words, avoiding the use of variables as much as possible and avoiding the use of quantifiers as much as possible. So statement A is saying there exists an X. So ganun lang yun, parang paano natin siya binabasa. Pero parang ayaw natin gumamit ng variables. So we want to use a non-symbolic subject in our sentence. So it says here that there exists a real number such that x squared is equal to 2. So basically, we can translate it into a more formal or a more informal statement, such as this way. So we can say that there exists at least one real number whose square is equal to 2. So in-avoid talaga yung paggamit ng variables, ng symbols, at saka ng quantifiers. Okay. Now, on the other hand, look at statement B. For all x in P, so for all, so you can say all. So all prime numbers, kasi yung P ay set of all prime numbers. So you can say all prime numbers is either odd or equal to 2. Okay. Right. So let's try example exercise 19. So for this exercise, nag-define pa pala siya dito ng new sets. Si double struct S, set of all integers divisible by 6. Double struct T, set of all integers divisible by 2. And double struct V is the set of all integers divisible by 3. Okay. Any volunteers to translate statement A into words? Mas madali pala to. Okay, Bea.
Number 1 po. All set of integers divisible by 6 are divisible by 2 and 3.
Work. This is okay, thank you. So here, this is saying that all numbers that are divisible by 6 are divisible by both 2 and 3. Okay, great. How about statement B? Statement B, any volunteers? Paano siya translate into English? Crisel. Pero naka-recite ka na yata, Crisel, no? So let's try others muna. Kung may mag-volunteer na iba na hindi pa nag-recite. Gusto ba next time may raffle? May random na sasagot? Or mas gusto nyo to, no pressure at all. So kayo nagde-decide kung gusto nyo magsagot. So no volunteers? So if there are none, Crisel, if you want to answer this or try to answer statement B, you can go ahead.
Ang sagot ko po is there is at least one integer that is divisible by 2, which is also divisible by 3.
Okay, so if I heard it right, you're saying there exists a number that is divisible by 2 that is also divisible by 3. Okay, so that is also that is great. So kasi existential lang naman. So merong integer na divisible by 2 na divisible then by 3. Okay. Now, any questions with translations before we proceed to a more technical aspect of the study guide? Okay, so if there are none, let's proceed. So here we'll look at negations of quantified statements. Kasi kung mapapansin nyo, maraming gamit yung pag-negate ng quantified statements. This is basically one of the key steps in proving something by contradiction. Or in your search for a counterexample, the negation of your quantified statements might play also a big role. All right. So in general, yung mga quantified propositions or quantified predicates ay pwede nating i-qualify or further divide into 4 classes. So case 1 is a statement that everything possesses the property P. Second statement, something has the property P. So ito yung existential quantifier. Pero posibleng merong negation operation inside the propositions. So for instance, in part C, for all x, not P of x. So basically, this statements falling under this category are characterized by a claim that nothing has the property P, or no element of the domain satisfies the property P. Now, kapag ka nilagyan nyo naman ng tilde o ng negation yung proposition sa loob ng isang existential quantifier, that means something does not have the property P, or there is at least one element of the domain that doesn't have the property P. Okay? So before going into details of these four types of quantified statements, let's try to see how do we negate statements involving quantifiers. And hopefully these things will come in naturally. Siguro simulan natin by an intuitive look at it. So let's look at this statement. For all x in A, P of x. So kung gusto natin siyang i-negate, gusto kong makahanap ng statement na ang truth value ay true kapag ka false yung original statement. And ang truth value niya ay false kung true yung original statement. Because remember, the negation of a proposition has the opposite truth value. All right? So itong statement na to, kailan nga to nagiging true? Nagiging true itong universally quantified predicate if this is true for all elements of the domain. So nagiging totoo itong statement na to kapag ka true siya sa lahat ng element ng domain. So kailangan kong hanapin yung negation niya, and the negation will happen when this statement becomes false. Kailan nga nagiging false itong statement na to? Ang isang universally quantified predicate? Can anybody remind me? Kailan nagiging false ang isang universally quantified predicate? Let's see who raised. Oh, Gab.
Magiging false po ang universally quantified statement kapag po mayroon at least one na hindi po nasa-satisfy yung yung statement po.
Okay, great. Thank you, Gab. So tama. Nagiging false yung isang universally quantified statement pag may at least isang element ng domain na nagpapa-false o hindi nakaka-satisfy dun sa statement. So it then follows, at least intuitively, that the negation of this statement para maging false siya ay ito. Dapat may mahanap kang isang element ng domain na hindi totoo si property P. Okay? And then, yeah, so basically that's how we negate a universally quantified statement. And actually, if you look at it in symbols, probably this will make sense if you are more algebraic or visual in nature or more formal in nature. Yung negation, pumapasok siya dun sa statement. Kaya nilagyan to ng parentheses to illustrate that the negation goes inside or gets distributed over the quantified proposition. So yung for all, papasok siya dun muna sa quantifier. So yung so magkakaroon ka ng negation ng quantifier, hindi daw siya for all. So ibig sabihin ang negation niya ay there exists. Kasi hindi siya para sa lahat, so posibleng totoo lang siya para sa ilan. Okay? So hindi siya for all, so there exists siya. Kasi dalawa lang naman yung quantifiers natin. It's either a for all statement or it is an existential statement. Okay? And then hindi lang doon, hindi mo lang kailangang i-negate o kunin yung opposite ng quantifier, but the negation also goes inside the proposition. So kaya kung mapapansin nyo, merong not P o may tilde dun sa simula nung proposition P o nung symbol P. Kasi again, the negation goes inside the predicate, the quantified predicate. So that means we need to negate both the quantifier and the statement itself. Okay? Now, on the same token, ganun yung para sa existentially quantified predicate will follow the same pattern. Again, let's go by intuition. There exists an X such that P of X. So sabi niya, meron daw isa, at least isang element ng domain na nakaka-satisfy kay P. So para maging false yung statement na yon, kailangan sa lahat ng element ni A, dapat hindi totoo si P. Alright? So if you want to negate this, ang negation niya is lahat ng element ng domain ay hindi nakaka-satisfy kay statement P. So in symbols, we have this. And again, you can look at it from a symbolic or analytic point of view, or Boolean algebraic, parang sa comsci working with symbols. So yung tilde, papasok siya sa there exists. Kailangan nating i-negate yung quantifier. So instead of a there exists, the negation will have a universal quantifier for all. Okay? And then the tilde will also go inside the proposition itself or the predicate itself. So in-negate din natin yung predicate. So instead of a P, we'll have a not P. Okay? So we'll stick to this. Pero some books or some references has this as the negation. Gumagamit sila nung mirrored E, tapos nilalagyan nila ng cross o ng slash mark. Ibig sabihin, ang basa dito ay there exists no. So there exists no element of A such that P of X. So posibleng ganito rin yung translation. Kaya lang, ayoko sanang ipakita tong symbol na to kasi gusto ko ipakita yung distribution nung tilde over the entire proposition. So kailangan mong i-negate yung quantifier at saka yung predicate. Pero I hope you will see that these two guys are synonymous with each other. Kasi sabi nito ay sa lahat ng X, hindi daw totoo si P. When you read this means walang X kay A kung saan totoo si P. So basically, sa lahat ng element ni A, hindi totoo si P. Right? Kasi wala ngang element ni A na totoo si P. Okay? But probably for now, let's focus on this. Ito na muna yung gamitin natin na negation or symbolic negation ng isang existential statement. Okay? Let's look at some more examples. Oh, but before we go to examples, let's go back to the 4 types of statements that we have mentioned earlier. Sabi natin, meron kang all x's have the property M. Ito yung statement type number 1. Tapos ito yung statement type of statement 2. There exists an M such that there exists an X that satisfies property M. Ito yung number 3. For all X, not M is true. And then there exists an X such that not M of X. Now, these 2 statements here are called contraries. So itong statement na to is contrary to this one and vice versa. Now, if you have 2 statements that are contraries or are contrary to each other, then yung mga statements na to can be both false, pero hindi sila pwedeng maging true at the same time. Pero tama nga ba? Both false, possibly both false, but not both true. But not possible to be both true. Okay, posible daw silang maging parehas na false, pero hindi sila pwedeng maging parehas na true. Bakit? Let's see. For all X, M of X. So sa lahat ng X, totoo si M of X. Tapos dito, sa lahat ng X, hindi totoo si M. So ibig sabihin, kung meron kang isa na element ng domain, kung saan totoo, hold on. Tama nga ba? Possibly both false sila. Sabi nito, sa lahat ng X, totoo si M. Ito, sa lahat ng X, hindi totoo si M. So, ibig sabihin, pag meron kang isang element ng set na totoo si M, at saka isang element na hindi totoo si M, so these 2 statements here will be both false. Right? Kasi nakakita tayo ng isang element na hindi totoo si M, tapos nakakita tayo ng isang element na totoo si M. So that means there is a possibility that both of these statements will be false. Pero hindi sila pwedeng maging true ng sabay. Kasi pag naging true sila ng sabay, ibig sabihin sa lahat ng X totoo si M, sa lahat ng X hindi totoo si M. So yeah, hindi sila pwedeng maging true ng sabay. So statements that are like this are called contraries. Okay. Analogously, these 2 statements here are sub-contraries, meaning possibly they are both true, but it is impossible to be both false, but not both false. Okay? Bakit? Pwede daw silang sabay na maging true. Kasi ano lang ba yung claim? Merong X na totoo si M. Merong X na hindi totoo si M. So if your domain has different behavior, or there are at least two elements of your domain that has a different disposition or different behavior insofar as statement M is concerned, so posible maging true ito at saka posible maging true ito. Basta hindi homogeneous yung domain. Or ibig sabihin, iba-iba yung property nung o yung reaction ng elements ng domain sa statement M. So, posibleng totoo sila parehas. Pero hindi sila pwedeng maging false ng sabay. Let's see. Merong X. So, kung false ito, ibig sabihin walang X na totoo si M. Tapos ito ay walang X na hindi totoo si M. So, basically, intuitively, hindi talaga sila pwedeng maging false ng sabay. And such a pair of statements are said to be subcontrary to each other. Okay. And then the crossings here, okay, they are contradictories to each other. When we say contradictory, magkaiba lagi yung kanilang truth value. So basically, they are the negations of each other. So if you negate for all x, m of x, remember, naninegate din, naninegate parehas yung quantifier at saka yung predicate. So instead of a for all, you'll get a there exists. Instead of an m of x, you'll get not m of x. So ito pala ay negation lamang nito. So that makes them opposite to each other, or we call them contradictions to each other. So ibig sabihin magkaiba sila lagi ng truth value. So if this is true, automatic ito ay false. Kung ito ay false, automatic ito ay true. Kasi nga contradictory sila. The same scenario happens to these two statements that are contradictory to each other. Okay? Perhaps later we will encounter statements that are contrary to each other or sub-contrary to each other. Now, this is also a common pitfall among students when they try to negate a certain statement. Sometimes they forget to negate the quantifier. So minsan ang sagot nila sa negation ng for all x, m of x ay ito. Ang ninegate lang nila ay yung predicate. But that will be wrong kasi di ba ang usapan pag negation, magkaiba sila lagi ng truth value. Pero if you treat this to be the negation, mali ka na. Kasi posibleng false silang dalawa. Para sa negation, dapat automatically magkaiba sila ng truth value, but there is a possibility that this would be both false. And then the same thing happens pag nakalimutang i-negate. Ganun din pala yung ginawa dun sa bottom 2 na ni-negate lang yung predicate. I don't know what's the relationship between these two kung may tawag sa kanila. Pero I will look at that and see kung may terminologies dito sa dalawa. Pero actually, halos I don't think meron silang terminology para sa kanilang dalawa kasi naiba lang naman yung quantifier. So let's leave it like that. So ito lang yung mga terms na na-introduce ngayon. Okay. Now, utang uli ako ng 5 minutes para sa recitation dito. Maybe some of your classmates would like to try to answer these. Okay. Example 21, kunwari wala dito yung sagot. So, burahin ko yung sagot. But anyway, let's try example 21. Let's read the instruction first. Write the formal negations of the following statements. So, formal negation ng mga sumusunod na pangungusap. Any volunteer for statement A, which says, for all real numbers, x squared is non-negative. Okay. Any takers? For all real numbers, x squared is non-negative. So, any volunteer? Perhaps it would be easier to first write this in symbols. Tapos pag na-symbolize na natin, saka natin kunin yung negation para mas clear paano siya ginagawa. No takers? So let me try this one. Let's think about it together. So for all real numbers x, x is non-negative. So yung translation niya into formal language ay for all x in R, okay, x squared is non-negative. So that means x squared is greater than or equal to 0. Okay? Now, if we want to negate this, kukunin ko lang yung, lalagyan ko lang siya ng tilde sa unahan, pero I'll put a grouping brackets here para maalala ko na yung buong statement yung gusto kong i-negate. So that signals to me that the negation will go inside the quantifier. So yung for all kanina, magiging there exists. Okay. And then the tilde will also go into the predicate. So in-negate ko rin yung predicate. So not x squared greater than or equal to 0. So you can say, okay, pwedeng ganito yung pagkakasulat. X squared not greater than or equal to 0. Or you can translate it into a less than symbol. So the formal negation of statement A is there exists an x in R such that x squared is less than 0. Okay? And I hope when you translate this and you try to put them into informal language again, makita nyo talaga that this is contradictory to statement A. Okay? Now if I'll try statement B, may gusto ba mag-try ng statement B? Any takers? Oh, yes, JR, go ahead. So I guess JR is typing it in. So JR typed in for all prime numbers P such that P is odd. Maybe I'll try to rephrase it a little bit. So for all prime numbers P, P is odd. Okay. So let's see if that works. May dinagdag siya. Okay, but I guess JR, your first answer is correct because I see here there is a there exists. So pag kinuha natin yung negation, dapat magiging for all siya. So I guess your first answer is correct for all prime numbers P. P is odd kasi hindi siya even. So again, let's start probably by translating it. Thank you, JR. So let's start by translating it into symbols first. So yung formal statement dito either exists a P in R, a P in P, set of all prime numbers, such that P is even. Okay. And then if we try to negate it, lalagyan ko siya ng tilde sa unahan, tapos grouping symbol, tapos papasok yung tilde doon sa there exists. So magiging for all, P and P, right? So hindi nababago yung statement along with the with the quantifier. Yung quantifier lang talaga yung binaligtad ko. So kung for all P and P siya, kung there exists P and P siya, magiging for all P and P yung negation. And then ang susunod ng pupuntahan ng tilde ay dun sa statement itself. So for all P and P, you can say P is not in E. So pag kapag pala for all, nawawala na yung such that. Kasi parang naging for all P and P, P is not in E. So parang nawawala na sa sentence yung such that. Usually yung such that, ginagamit lang natin siya para sa mga existential quantifiers. Okay. So para maging mas natural yung translation or mas grammatically correct yung translation. Okay. Or we can go by JR's suggestion. Now, pwede kong sabihin instead of P is not even or P is not in E, I can just say P is odd. So pwede kong gawing P is an element of double struct O. Right? So the negation of this statement is that for all prime numbers P, P is odd. Okay. So, all right. So again, bottom line here is if you want to negate a quantified predicate or a proposition, so you need to negate the quantifier so that the for all becomes a there exists, and then the there exists becomes a for all, and then you also negate the predicate. Okay, so yun lang yung bottom line dito. So there are other examples here. So kindly look at examples 22 and 23 bago kayo mag-hibernate yung weekend. Now, on Monday, I'll ask your recitation, your laboratory instructors to talk to you about statements with more than one quantifier. So, posibleng sa isang sentence, merong mga phrases that have their own quantifiers. So, for instance here, medyo cheesy nga lang yung example. So, pardon the cheesiness. So, pero for example, for all people X, there exists a person Y such that X loves Y. Sana all. Pero anyway, so meron kang dalawang quantifiers. Merong for all dun sa for all people. Tapos may there exists dun sa kabila. And then statement B, there exists a person Y such that for all people X, X loves Y. So siguro pwede nyo rin itong simulan ng pag-isipan. Pero your lab instructors will talk to you about this on Monday. So two things. What is the difference between these two statements? So nangyari lang naman, nabaliktad. Yung for all, nauna yung for all, tapos there exists. Sa statement B, nauna yung there exists kesa yung for all. Tapos siguro makikita nyo na yung rule of grammar dito. Kapag ka may there exists, pwede yung sundan ng such that. Kapag ka for all, wala ng such that na kailangan para maging mas natural lexicographically yung pagkaka-translate. Okay? Now, the challenge here is to try to negate statements that involve more than one quantifier. And that's what you'll do on your lab or your lab classes on Monday. Okay? So any questions before we end? Oh, by the way, those who recited, especially those who recited purely verbally, kindly put a comment in the meeting chat. So, okay. Pwede nyo naman siyang gawin after we end the meeting, pero yeah. Kung gusto nyo gawin ngayon. Any questions? Yes, Bea?
Sir, wala pa rin po akong access sa mga comments, yung mga chats po.
Okay, no problem, Bea. I'll add you here.
Sige po, thank you po.
All right, you're welcome. Sino pa yung nagsagot verbally na walang access sa chat? So probably if you don't have an access yet to the chat, probably it's because you are not a member of the team yet. So kung hindi pa kayo member, please try to become a member. All you need is your @outlook.up.edu account. So kung wala pa kayo noon, mag-request kayo sa UPITC. It comes with your with an Office 365 subscription provided for by the university. So free na siya sa inyo. So you can download Office 365. Tapos pag nag-request kayo, bibigyan nila kayo ng @outlook.up.edu.ph login credentials. So yun yung gagamitin nyo para mag-join ng Teams at mag-download ng Office 365 kung kailangan nyo pa siya, like MS Word, MS Excel, and all of the accompanying apps there. Yeah. Pero kung meron na kayong @up.edu.ph na email ad, yun yung ginagamit kong pang-add sa MS Teams. Kaya lang hindi kayo makaka-login kung wala pa kayong @outlook.up.edu.ph na account. Hindi ko alam kung bakit ganun yung setup ng Microsoft, pero kahit saan siya, kasi ganito rin yung gamit ko dun sa US last semester. Pinang-login talaga namin ay Outlook dun sa MS Teams saka sa Office 365. Pero yung email na lumalabas ay pwedeng UP email din. So probably I have invited you kasi may UP email na kayo. Pero hindi kayo maka-login kasi ang kailangan pang login ay yung Outlook credentials. So if you haven't done so, you can request, take advantage of all this free stuff the university is providing us. Okay? Anyone else na nagsagot verbally without access to the chat? Okay. So if everything is in order now, so let's end here. Thank you guys for staying late today. Lalo na ito na yung last day of the week. So enjoy the rest of the night, and also enjoy the weekend. Take some rest, and then let's see each other again on Wednesday. Bye, everyone.